This is a question which no one should have got wrong. If you took your time and did it properly, instead of actually being cocky and doing it without doing working out. So let's do case all values. 1, 2, 4, 8. That's an 8 by the way. 16, 32, 64, 128. So if you work out the arrows to start off with, we've got 4, 5, so that'll be 0, 5 on the stopwatch. For minutes, 2 plus 8 is 10, plus 16, so we've got 10 plus 16, which equals 26. And finally, we've got 32 plus 16, which is 48. So we've done that. Plus 4 is 52. So we've done that. And plus 2 is 54. Oh, I forgot that one as well. So 55.
Okay, so we know that the CPU does 3 things: fetch, decode, execute. So the CPU, something data. Well, it fetches data. It doesn't transmit data, it fetches data. So I'm going to do F for fetch. So that is this one here, number 1. And it also fetches the instructions. So if you've got RAM, and you've got the address, A for address, and D for data or instructions, D/I, it'll go to address number like 201 and get the data from it. It stores them in the IAS, so IAS, which basically is like a holding cell. It's not a register, it's just there to hold it. Like a waiting room for the data to be, for it to be processed. The something holds the address of the next instruction, so let's go through it. When you fetch instruction, you've got the IAS, which is like the holding room. You've got the program counter, which gets the first address you need. It then sends it to, or copies it to the MAR. So 201. It'll then go to use the address bus, it'll go to the RAM, it'll then put out the data from 201 and put that data into the MDR. So in the MDR it'll be 0101. It will then decode and it will then execute the instruction. Now if there's calculations, what will happen is calculations are actually done in the ALU, and inside the ALU you've got the accumulator where the data is held during these calculations, like adding up, etc. So if we go back to this, the something holds the address of the next instruction. So it's always going to be the program counter, PC, which holds the address of the next instruction to be executed. This address is then sent to, or copied to, the MAR. The data from this address is then sent to the MDR. Now, some of you put address bus, etc. Now, the address, even before it goes to the address bus, goes to the MAR. Now, if we did have an address bus in this question, it will say, it'll use the word transmit. So transmits, the address bus transmits the address. But it doesn't say transmit here. The next bit says the data. So that assumes we've actually gone into the RAM, and we pulled out the data. So the data is then copied to the MDR. The instruction then can be decoded and executed, which a lot of you did put, which is great, well done. Any calculations are carried out by the ALU. During calculations, the data is temporarily held in a register called the ACC. Now, if it mentioned anything about control signals, etc., that's where the control unit comes into it. If it talks about transmitting the data from the RAM back to the CPU, you're talking about the data bus, because we're using the word transmit. So there's keywords in here which you guys need to get familiar with. Address bus will be transmit the address. Data bus will be transmit the data. Program counter, control signals. So this question was done pretty poorly. This is a type of barcode. So someone who would type in barcode, sorry, answers barcode, no. Look at the question, it says, what is this type of barcode? It is QR. So how's data stored in this barcode? Well, number one, it is read, or if you use the word scanned, using an app. Number two, the camera that's on the phone is used to scan. Number three, the three large squares are used to define the alignment. Four, the black squares reflect less light, white more light. Five, the app processes the image, and six, each small square is converted into binary value. You can mention 4 things from that list. Look at what you did. Okay, so basically the exam have got rid of echo check, so I don't want you to use echo check in future. If you've done it for this exam, I'll give you that. So parity check is out of the question, so we can't use parity checks like parity blocks or anything like that, so you can't talk about that. What you can talk about is checksum, which is calculation carried out on data. Another point is that the value is sent with the data, the checksum value. It is recalculated after transmission and compared to the original. If they do not match, an error is present. So it does a calculation for a checksum, it comes up with number, it will then send it with the data. So if I'm sending you something to your computer, this is me, my computer's done a checksum and let's imagine it's come up with 21. It sends the data to your computer, this is a video, so you get the video, happy days. And it also does the calculation on your computer. If it comes up with a different number, there's an error. So it's compared. If it comes up with the same, there's a match. Happy days. The next one you can do is ARQ, which uses acknowledgement and timeout. A request is sent with data to acknowledge or data is received. The acknowledgement is sent back to say or data is received. If no acknowledgement is received in time frame, an error in transmission has occurred, data sent again. Oops, spell mistake. And there you go. That's pretty standard. Okay, so this question would have been easy if you revised touchscreens. Now there are different types of touchscreen. This is a capacitive touchscreen. So it uses what's called a conductive layer. And what happens is this: you've got an electric field, or you can say electrostatic field, is created. There's sensors around the screen. And those sensors monitor the electrostatic field, or the electric field, whatever you want to call it. You then have, when it is touched, there is, so when the screen is touched, there is a electrostatic charge which is transferred to the finger. The location of where you touch the screen is calculated and coordinates are used. Okay, so explain why the touchscreen will not work if you're wearing gloves. Well, gloves are not conductive. They're actually insulators. Therefore, they block the gloves, block any current or charge from your finger. It stops the gloves, stop the electrostatic field being changed, disturbed. Now, a second, if she did not want to remove the gloves, what could she do? Yes, Adam, you would have got the mark if you said bite the gloves so that you take off the tip of the gloves, but that's not what the exam board really want. Use a stylus. This allows the charge to be disturbed. So I'm putting a idea and then explaining it. Capacitive glove, so these are special gloves, allows the charge to be disturbed. She could use voice commands via natural language. You could have mentioned one idea and then one explanation of it. The key is, if you're using capacitive gloves, it allows the charge to be disturbed, which means basically that it can register the coordinates of where you've touched it. Same with a stylus. Voice commands via natural language, that's a key bit. Voice commands, natural language.